This is video number 3 for the 2.6 notes. We're going to continue with example number 7. And if you guys take a look at the question, we want to find the constant a so that the function is continuous on the entire real line except for x equals 0. So when you look at the piecewise function, we have f of x is equal to 4 sine of x over x if x is less than pi over 2, and a minus 2x if x is greater than or equal to pi over 2. So, except for 0, the only other place that this function could be discontinuous would be where you change from one function to the other, which is pi over 2. So we want these two functions to be equal to each other at pi over 2. So what I'm going to do is I'm going to set up an equation where I substitute pi over 2 in for x and set these expressions equal to each other. So if I have 4 sine of pi over 2 divided by pi over 2, and that would need to equal a minus 2 times pi over 2. So now I have an expression that's going to allow me to solve for a. If you remember, sine of pi over 2 is 1. So the numerator is 4 times 1, which is going to give me 4. Instead of dividing by pi over 2, I'm going to multiply by 2 over pi, just multiply by the reciprocal. And then on the right side of the equation, I'm going to have a minus pi. Now we want to solve for a in this case. So we're going to get 8 over pi equals a minus pi. Now to isolate a, which is what we're looking for, we can add pi to both sides and come up with an answer of pi plus 8 over pi equals a. Another way potentially to write that answer would be to get a common denominator of pi. So you're going to multiply pi by pi over pi, which would give us pi squared plus 8 over pi. And that would be the value of a. That would make that function continuous for all real numbers except for possibly 0, because the numerator would be undefined at 0. Okay, let's take a look at the next idea. So now we have something that's called the intermediate value theorem. And this is really the first theorem we're going to talk about. So we're going to shorten it as the IVT. But here's the conditions. If f is continuous on the closed interval a to b, and L is any number between f of a and f of b, then there is at least one number c in the closed interval a to b such that f of c equals L. So what is this saying? Basically, if we have some function that is continuous from a to b. So I'm just going to go ahead and draw some function here. Maybe it looks like this. So let's say that this is a and this is b. That's going to make this height down here f of a, and this height up here f of b. Or you could think of this coordinate being a comma f of a, and this coordinate being b comma f of b. Essentially, all the intermediate value theorem is saying is that when the function is continuous, that somewhere on the interval from a to b, there's a value c such that every value between f of a and f of b exists. So everything from this value f of a to this value f of b is going to exist somewhere on that interval. Because with continuity, we're going from this point to this. A lot of times, we're going to use the IVT to essentially prove that a function has a 0 on a given interval. So let's take a look at example 8. It says, explain why the function has a 0 in the given interval. We have g of x is equal to negative 4x plus 3. And we want to prove for the interval from negative 5 over 2 to 4. Well, what we know, hopefully, is that this is a linear function, and linear functions are continuous for all real numbers. So what we're going to do is we're going to go ahead and evaluate the function at each endpoint. So we can do g of negative 5/2, which is going to give me negative 4 times negative 5/2 plus 3. If we simplify this, that's going to be 20 over 2, so 10 plus 3, which is 13. So g of negative 5/2 is 13. If we plug in 4, we've got g of 4, which is going to be negative 4 times 4 plus 3. Negative 16 plus 3 is negative 13. So g of 4 is equal to negative 13. Well, because one of these endpoints is positive and the other endpoint is negative, somewhere on that interval there has to be a 0. Because every value, every height from negative 13 to positive 13 is going to exist at least once. So now we got to work on writing an answer providing all the reasoning. Okay, so basically we would say something along the lines of g of x is continuous on the closed interval from negative 5/2 to 4, and g of negative 5/2 is greater than 0. G of 4 is less than 0. So by the IVT, there exists a value c on the interval negative 5/2 to 4 such that f of c equals 0. And one of the things that's going to be important that we learn is that whenever we're using a theorem to justify an answer in a problem, is we have to make sure that all of the conditions of the theorem have been satisfied. And in this case, it's purely that the function has to be continuous on that closed interval. All right, guys, that's it for this video. If you guys have questions, make sure to ask your teacher in class. You can always rewatch the video, pause, rewind if you need to. All right, guys, have a good day.